Welcome to OStats, a platform for short statistical hacks. This video will cover the null hypothesis. There are lots of fancy ways of explaining the null hypothesis, but put simply, it is expecting no real difference between the things that you are testing, so any difference that is seen is due to chance. We use the null hypothesis as a way to interpret conclusions about differences between two or more population parameters or two or more observations. The ability to accept or reject the null hypothesis relies on the p-value, and the alpha level for the p-value that is typically set at less than 0.05 or less than 0.01. This determines whether a statistically significant relationship exists, which is explained further in another video. The alternative to the null hypothesis is literally the alternative hypothesis. It suggests there is a real difference between the things that we are testing. For example, you could have a number of alternative hypotheses when looking at differences between different pieces of fruit. H1, or hypothesis 1, could be that there is a difference between oranges and apples. H2 could be that there's a difference between apples and pears. And H3 could be that there's a difference between bananas and oranges. And so the numbers go on, dependent on the number of hypotheses that you have. There must be no difference for the null hypothesis to be accepted, so the results can be equal to, or less than or equal to, or greater than or equal to for the null to be accepted. By contrast, there must be a difference for the alternative hypothesis to be accepted, so the results must be not equal to, or greater than, or less than. It cannot be the same. You presume the null hypothesis to be true until scientific evidence indicates otherwise. So in effect, you are always trying to disprove or reject the null hypothesis in any given investigation. The problem is that you can incorrectly accept or incorrectly reject the null hypothesis. Likewise, you can incorrectly accept or incorrectly reject the alternative hypothesis. So you effectively end up with 4 cells, with 2 possible correct answers and 2 alternative errors. If the null hypothesis is true, meaning there is no difference, and we accept the null, then we are correct in doing so. If the null hypothesis is false, meaning there is a difference, and we reject the null, then we are correct in doing so. But if the null hypothesis is true, meaning there is no difference, and we reject the null, then we have a type 1 error. What we are saying here is that there is a significant difference in our investigation, but this is not true in the real world. Also, if the null hypothesis is false, meaning there is a difference, and we accept the null, then we have a type 2 error. What we are saying here is that we fail to find a significant difference in our investigation, but one actually exists in the real world. The probability of correctly accepting the null hypothesis is equal to 1 minus alpha. Alpha is typically set at 95 or 99%. That means you have a 5% or a 1% chance of incorrectly accepting the null. The probability of correctly rejecting the null hypothesis is equal to 1 minus beta. Beta, or beta, depending on where you are in the world, is typically 80% and relates to power, discussed in another video. This means you have a 20% chance of incorrectly rejecting the null. And that's OStats. If you like this video, consider subscribing to our channel for more short statistics.